Okay, here we want to look at two functions, and we want to use the first derivative test to find the relative maximum and minimum. And on the second one, we're going to also use the second derivative test to find the maximum and the minimum. You can have your choice. Some people like the first derivative test, others people like the second derivative test, but we just want to show how you use each test. Now, first, let's look at our function. F of x is equal to x to the fourth minus 4x cubed plus 5. So the first thing to do to find we want to find the first derivative. Let's set the first derivative equal to 0, of course, to find our critical point. So that's going to be 4x cubed minus 12x squared equal to 0. You come back. That's 4x cubed minus 12x squared is equal to 0. Now, of course, we factor out the greatest common factor, which is going to be 4x squared. So that's going to be x minus 3 equal to 0. And now we set both of them equal to 0 to solve it. So that's going to be 4x squared equals 0. So x is equal to 0. And on this side is going to be x minus 3 equal to 0. So x is equal to 3. Those are our two critical points. These are our two critical points. All right. Now, what we do, we want to set up a number line with our critical points. This is a key step. We want to set up a number line. On this number line, I'm going to put my critical points, 0 and also 3. Now, into this first derivative, the first thing I'm going to put any number smaller than 0. You can use any number. Some people use -1, some people use -5, some people use -8, it doesn't matter. Then we're going to use any number between 0 and 3. Basically 1 and 2. And then we're going to use any number larger than 3. We're going to put these in this first derivative here to see if they're positive or negative. So the first thing, and I'm going to do this one just to show my test value, I'm going to use a different color here. I'm going to use a -1 for my test value. Okay. Now, if I put -1, 4x squared, 4 times -1 squared will give me a positive number. And -1 minus 3 will give me a negative number. So positive and a negative is going to make that into a negative. Now I'm going to put a 1 in. I could choose 1 or a 2. I just need to use anything between 0 and 3 to satisfy this interval. So let's just choose a 1. I'm going to choose a 1 right here. All right, so let's go back. 4 times 1 squared, that's positive. 1 minus 3 is negative. So this, again, is going to give us what? A negative result. All right. And now I want to come back and choose any number larger than 3, just for the sake of making it simple. Let's just choose 4. You could choose 4, 5, 6, 10, 20, anything. All right. But once we plug this number in, 4 times 4 squared, that would be 64, and 4 minus 3 is 1. 64 times 1 is 64. That's a positive number. So we simply come here, and that number will be positive. Okay, so now it goes to 0. You have a negative and another negative here. So there is no relative maximum. But here it changes at 3. So we know that we're going to have a relative minimum because it's going down at 3. And now let's plug 3 back into the original function. 3 to the 4th power is 81. 3 to the 3rd times -4. Remember the order of operations. That's negative 108. So that will be 81 minus 108, which is negative 27. And negative 27 plus 5 will give us a negative 22. All right. So that's how we find the relative maximum and minimum using the first derivative test. We can go back, we can see where it's decreasing. It's going to decrease all the way from negative infinity to 3. It's going to hit that minimum point. And once it hits this minimum point at 3, negative 22, the interval is going to increase from 3 to infinity. That's how we use the first derivative test. Find the relative minimum. Now, let's use this one. So now, for the, we want to use the second derivative test. We're still going to have to find our critical numbers, which we already know. We've already done the work to know our critical points are going to be 0 and 3. I'm just going to show it all the steps again. That's 4x cubed minus 12x squared. So just to save a little time, let's just say our critical points are going to be 0, because we've already done the work on the other side. Our critical points are going to be 0 and also 3. These are our critical points. But now here's the difference. Now we need to find our second derivative. We need to find our second derivative. That's why this is called the second derivative test. So the second derivative is 12x squared minus 24x. All right, 12x squared minus 24x. So now this is what we do. We need to plug our critical points into our second derivative. Our critical points into our second derivative. Remember, you can use your notes here. Once we plug our critical points in, if our answer is greater than 0, we have a relative minimum. If it's less than 0, we have a relative maximum. But if it's equals 0, our test fails. Like I said, you have the notes and everything right there or somewhere so we can go. So now let's go with it. F double prime of 0. Because we're going to plug our critical points now into the second derivative. So that's actually going to give us 0. So it fails at 0. But we know that's okay because it failed at this 0, because it didn't go plus or minus plus. It was 0 and 0. So nothing's happening at 0. even though that's a critical point. Okay, now let's look at F double prime 3. Like we said, use your notes right here. That's 24 times 3. So this is going to give us 108 minus 72, which is equal to, what is that, 36? So now, if we remember, 36 was what? Greater than 0. So once again, we had a relative minimum. We had a relative minimum at 3. And once again, plug the 3 back into the original f of x function. That is 81 minus 108, which gives us a negative 27, plus 5, which gives us a negative 22. So once again, we could graph that. This is the difference between the first derivative test, okay, where we use the number line and see where our values are increasing and decreasing, and the second derivative test. Remember, the second derivative test is where we take our critical points, all right? We plug them into the second derivative. If our answer is greater than 0, we have a relative minimum. If it's less than 0, we have a relative maximum. And if it equals 0, the test fails.